Good afternoon, students. In last lecture we are studied redox balancing of redox reaction by oxidation number method. Next example of balancing of redox reaction is balance the following redox reaction by oxidation number method in a basic medium. Reaction is MnO4 minus plus bromide minus, it gives MnO2 and BrO3 minus. This reaction occurs in basic medium. Then steps involved in balancing of redox reaction. Step first, what is the step first? Step first is balance atoms except hydrogen and oxygen in unbalanced chemical equation. This is unbalanced chemical equation. In this equation, except hydrogen and oxygen, which elements are present or which atoms are present? One is manganese. Left hand side, one manganese is present. Right hand side, also one manganese is present. Therefore, manganese are balanced. Then bromide, one bromine, one bromine. Bromine is also balanced. That is step first. Write unbalanced equation and balance atoms other than hydrogen and oxygen. Atoms except hydrogen and oxygen. Plus minus, it gives MnO2 solid plus BrO3 minus aqueous. Then second step is assign oxidation number of all atoms in a reactants and products. Step second, assign oxidation number of all atoms MnO4 minus. We know that oxygen shows generally -2 oxidation state. Then what is the oxidation state of manganese? It is +7 plus Br minus. It is monoatomic ion. Therefore, its oxidation state is equal to its charge, that is -1. It gives MnO2 oxygen -2, therefore Mn plus 4 plus BrO3 oxygen -2 bromine plus 5. By observing oxidation number of all atoms, it indicates that oxidation number of oxygen -2, -2, -2 does not changes. Then oxidation number of bromine changes from -1 to +5, that means increases. It indicates that this bromide ion undergoes oxidation. Oxidation number of manganese changes from +7 to +4, that means decreases. It indicates that this MnO4 minus species undergoes reduction because its oxidation number decreases. Step third is identify atoms that have changed oxidation number. Step third, identify atoms that have change oxidation number and by how much? Oxidation number of bromine increases from -1 to +5, that is by 6 units. Oxidation number of Mn, that is manganese, decreases from +7 to +4, that is by 3 units. This is the step 3rd. Then what is the step 4th? Determine factor that will make total increase in oxidation number and total decrease in oxidation number will be equal. Therefore, oxidation number of bromine increases from -1 to +5, that is by 6 unit, and oxidation number of manganese decreases from +7 to +4, that is by 3 unit. Therefore, we have to equalize that total decrease and increase in oxidation number by multiplying suitable factor. Here, if we multiply by manganese by 2, then it is also 3 multiplied by 2, 6. That will make total decrease and increase will be equal. Therefore, step 4th, determine factor. Step 4th, determine factor that will make total increase and decrease are equal. Determine factor that will make total increase and decrease equal. Increase and decrease equal. And insert that coefficients in our unbalanced chemical equation. Then we have to multiply it by 2 atom Mn that will appear in the reaction. Therefore, twice MnO4 minus in aqueous state plus Br minus, it gives twice MnO2 in solid state plus BrO3 minus in aqueous state. Here I have inserted already that factor, that means 2, which make total decrease and increase in oxidation number equal. Then step 5th is balancing of oxygen. Balancing of oxygen. Oxygen atoms. In previous lecture we are already discussed how oxygen are balanced. Count total number of oxygen on left hand side of the equation. 4 multiplied by 2, that is 8. Right hand side, 2 multiplied by 2, 4, plus this 3 oxygen. Left hand side there are 8 oxygen and right hand side there are only 7 oxygen atoms. Therefore, At right hand side of the equation, one oxygen atom is less. Therefore, we are going to add one water molecule to the side containing less oxygen atom. It indicates that there are 7 oxygen atom towards right hand side, that is 1 oxygen is less. Therefore, we are going to add 1 water molecule towards right hand side of the equation. Twice MnO4 minus aqueous plus Br minus aqueous, it gives twice MnO2 solid plus BrO3 minus aqueous plus 1 water molecule, water in a liquid state. In this way, oxygen are balanced. Then next step is balancing of hydrogen atoms. Step 6th, balancing of hydrogen atoms. For balancing of hydrogen atom, count total number of hydrogen on both sides of the equation. Left hand side equation, there is no any hydrogen, but at the right hand side of the equation there are 2 hydrogen atoms. Therefore, 2 hydrogen atoms are less towards left hand side of the equation. Therefore, we are going to add 2H plus ions at the left hand side of the equation. 2MnO4 aqueous plus Br minus aqueous plus 2H plus ions. We know that hydrogen are balanced by addition of H plus ions towards the side containing less hydrogen atom. It gives 2MnO2 plus BrO3 minus aqueous plus water liquid. In this way, hydrogen and oxygen are already balanced. But next step is, this reaction occurs in basic medium. Therefore, one of the step the reaction occurs in basic medium is add OH minus ions, that is hydroxyl ions, on both sides of the equation equal to H plus ion in the equation. Here 2 H plus are present in the reaction. Therefore, we have to add 2 hydroxyl ions on both sides of the equation. This step is only for reaction occurs in basic medium. Step 7th, since reaction occurs in basic medium, therefore add H plus ions, add OH minus ions, that is hydroxyl ions, equal to H plus ions on both sides of the equation. Both sides of the equation. This step is only for reaction that occurs in basic medium. Then we have to add 2 OH minus ion, because here 2 H plus are present in the reaction. Therefore, 2 MnO4 minus plus Br minus aqueous plus 2H plus aqueous plus 2 OH minus aqueous. It gives 2 MnO2 plus BrO3 aqueous plus 1 water molecule plus 2 hydroxyl ion. Because reaction occurs in basic medium, therefore we have to add 2 OH minus on both sides of the equation. Then this 2H plus and 2 OH minus is nothing but 2 water molecule. By combining this 2H plus and 2 OH minus, reaction becomes 2 MnO4 minus plus Br minus plus 2 water molecule liquid. It gives 2 MnO2 solid, BrO3 minus aqueous plus water liquid plus 2 hydroxyl ion. By observing the equation, it indicates that here 2 water molecule and 1 water molecule, 1 water molecule get cancelled. Remaining reaction is 2 MnO4 minus plus Br minus aqueous. It gives 2 MnO2 plus BrO3 minus plus 2 OH minus aqueous. Now last step, check the equation with respect to all atoms and charges that are balanced or not. Reaction indicate that on left hand side there are 2 atoms of manganese, right hand side there are also 2 atoms of manganese, that is manganese are balanced. Then 1 bromine, 1 bromine, bromine are balanced. Then next is oxygen. Next is oxygen. 4 multiplied by 2, 8 oxygen. Here 4, 7, 9 oxygen. Sorry, here out of 2 water molecule only 1 water molecule get cancelled. One water molecule is as it is. Sorry, here only 1 water molecule get cancelled. 1 water molecule is as it is. MnO2 plus BrO3 minus plus 2 OH minus aqueous. Now check the equation. 2 Mn, 1 bromine, 1 bromine. 4 multiplied by 2, 8, 8 plus 1, 9 oxygen, and right hand side 4, 7 and 2, 9 oxygen. Then number of hydrogen, left hand side 2 hydrogen atoms are present and right hand side there are also 2 hydrogen atoms are present. Now check the charges. On left hand side 2 multiplied by minus 1, minus 2, 1 multiplied by minus 1, minus 1. Total charge on left hand side minus 3. Then count charge on right hand side. 1 multiplied by minus 1, minus 1, and 2 multiplied by minus 1, minus 1, minus 2, minus 3. Charge is also balanced. In this way, this reaction is balanced. This is all about redox reaction. Then next point is application of redox reaction. We will discuss in next lecture.